And we'll just open up Excel. Okay, I'm recording. You can see my Excel file here, right?
Yes, yes.
So I should also open up the textbook. Teams, files. Let's open up the textbook. There we go.
This is going to be saved right in the same section, right?
This will be saved there, and I can put the link in an announcement. I think it should work. You should be able to see.
Wonderful.
So we're in chapter 4.
Yes.
That's 7.4. There we go. There's some problems. All right, let's look at this file. This is interesting. It's not a problem we do. What problem number is that? 431. So I go over here, my Excel, I bring it up. This is problem 4-31. That's what I mean by one sheet. Then if I open another sheet, I can do another problem here. Yes. And I can tell by the label what the problem is. So
okay.
I go over here and I open up screenshots and I bring this file over, and of course it doesn't.
I could clean that up for you anyway. I don't think it'd take me much.
Don't worry about it right now.
Okay.
Let's go over how to do this. So I have two variables here. I'm trying to see if there's a relationship between the payroll and the number of victories. And you can tell there's not, because the New York Yankees had, it's going to be weird because they had 209, but they had 89 victories. Los Angeles Angels had $119 million in salary and got 100 victories. So it's really hard to tell.
Sure.
So I'm just going to look at payroll. And I'm going to enter these numbers: 209.1, 138.7, 133.4, 121.2, 79, 67.2, 48. Everybody says data analysis is sexy. It's not sexy when you're doing this. And if you're entering hundreds of numbers, well, sure. Now most of the time you're just getting it off a computer. 98.6, 62.2, 58.2, 43.8. 68.2. Now, as I'm entering this, what would I want to do? What would be the dependent variable? What would be the independent variable?
The numbers are really small. I'm watching you do it, but
no, that doesn't matter. You can enter the number. That's the small part. If I'm going to use one of these to try to predict the other, which is the X variable? Did you read the chapter at all?
Yeah, I read through it. Yeah.
Okay, what is the dependent variable? What is the independent variable?
The payroll would be the independent variable, right?
Yes.
The victories come off the payroll.
I'm interested in not saying. I'm interested in trying to predict how, if I'm spending money, if I spend more money, do I get more wins? That's what you're trying to answer. So you're trying to predict wins by payroll. Sure. You're exactly correct. So this would be, if I was going to sign it, this would be my X, this would be my Y.
Right.
So the size didn't matter. I'm just entering data right now. I can't do anything on this because it's a picture. See what I mean?
Yeah.
So I have to make it numbers in Excel cells so that I hopefully I have not fat fingering it and putting bad numbers in here. 61 They don't have to be in any order either. The
Okay.
matches, the matching sides have to match each other. So 209 has to match 89, 138.7 has to match up. But this order doesn't matter. This order doesn't matter. If I want to reorder it, I can. When I graph it, it will fix itself and put it in order.
Okay.
86, 88, 75, 97, 79. Now, when I do this, I'm interested in making it look pretty too.
Okay.
I want everything in the column to have the same number of decimal places, which happens to be 1.
Okay.
So I just make it look nice, right? Because if I have to present this to anyone, I want it to look good. If I can clip and paste it in a PowerPoint and present it to some, client or senior management or something like that, I like to put boxes around my data. I like to bold the headers.
Okay. Sure, of course.
And maybe I'll put a little, color in the header. So now it looks nice, right? It's a nice little table. I'm trying to use X to predict Y. What I'm trying to do is get an equation that looks like Y equals some slope times X plus a Y-intercept. When X is 0, when does it cross the Y-axis? Now, this is 9th grade algebra, 8th grade algebra.
Sure.
7th grade algebra. Probably in China, it's 6th grade algebra. And I'm not teaching that. I assume people know it. If you don't know it, you got to figure out, go watch some videos and learn about lines. But they even explain a little bit of it. Now, first thing you do with any line is highlight the data, including the headers. It's okay. Go to, say, insert.
Okay.
And what you want to do is you want to insert a scatter diagram. Just look at the data.
Looking for that.
All right, there it is. I know the bottom is payroll, and this is wins. I'm going to eventually put that on there. Does it look like there's a relationship?
Pretty close.
Well, I could draw a line. I could put a line through there. In fact, before computers, when I first started working, we used to use really good graph paper, plot all this stuff, and then use a ruler.
Sure.
And estimate a regression line on it, and then find the slope of that regression line and find the y-intercept of the regression line and get the equation. But we're so far beyond that now that, if I go here to quick layouts and I go to the one that says FX.
Okay.
I click on that, it changes the graph and it gives me these numbers. It gives me my equation. It does the regression for me.
Yeah.
Now it gives me an R-squared of 0.0309. This is not really that great a model. And this is called simple graphical linear regression. You don't have to do any calculations. It's all point and click. Now you can watch this, and when you do that, it also gives you the axis. And the axis here is payroll in millions. And this is wins. You could say number of victories, but I'm just going to say wins.
Okay.
And if I want to change the title and make it wins versus payroll.
Oh, okay.
And it tells me now that my equation here is I multiply the payroll times 0.0436 and add 78 to it. Basically, I had 0 payroll, you'd expect to get 78 wins. Now, sometimes the y-intercept means something, sometimes it doesn't. In this case, it doesn't. In pure regression analysis, this line is valid from the minimum x value to the maximum x value, from the minimum y value to the maximum y value. So it really only applies to this space, like from 50 to 200 and change, and probably 60 to 100. Okay. This is the New York Yankees. Because I'm trying to fit a linear equation to it, this line is separate from the rest of the data. This point is so separate, it tugs the line in the direction of this point out here. If I was to get rid of that point and draw it, I'd even have a worse model. If I was to just not include the New York Yankees, which is number 1, I do the same thing. Insert. I'm going to put a scatter diagram down. Okay, it's different because I don't have the Yankees there anymore. I don't have the Yankees to kick around. Where did it go? Come on. Escape. Where'd my data go? There we go. There's my data. Let's see if I can do this and not lose data. Okay, there's my chart without the Yankees. So let me put this. Wins versus payroll without New York Yankees. Okay, I don't need this. Okay, now I'm going to put a regression line around it. Got the same thing. I don't need this. I only have one data series, so I don't need the key. Now my R squared has gotten even worse. My slope is even closer to 0. I would say this is not a good model. Either one of these I would say is not a good model. What does R squared mean? Do you remember that from your reading?
I was struggling with the R squared part in the reading. I couldn't find it in the book, so I gotta look into it deeper.
It's in the it's in the video, but you'll never see that. That's why we're making this video. Okay.
I appreciate it. Thank you.
No problem. And other students can look at this too. I mean, I don't know how many videos they're going to watch. At some point, you can't spend the whole week watching videos, I suppose.
All right.
Let's say I want to insert a text box. And I would put R squared another term for it is coefficient. This will mean nothing to anybody, of determination. Determination, wow. To put it colloquially, R squared represents the percentage of variation in the Y data that is explained by the regression model. Okay. Bold that up. That's what R squared is. I'll put that right there. So if I go here, this model, including the Yankees, explains 3.1% of the variation in the Y data. That's horrible. This one explains less than 1%, 0.8% of the variation. This is not a very predictive model to me. Now, there's more I can do with this if I want to look at it. And here's where we could use But first of all, I'm looking at it, and I don't see, with this point, I can see that I get a line that has a slight increase to it, but that's only because this line influences. Without this, it's very close to zero. If the slope, if it's a pure scatter diagram, in other words, there's no shape to the data, the slope will come out to be zero.
Okay.
So there's another way there's more analysis I could do. This is quick, it's graphical, it only works if you have one X variable and well, first of all, they only work with one Y variable, but sometimes we can have more than one X variable. And we'll do a model like that after this. And then you should be able to do all the homework problems.
Okay.
It may take you forever, but you can do it, and you can watch this video over and over again if you have to and figure out what did he do, what did he click on. All right. Now I have to use data analysis. If data analysis is kind of cool, it's under data. And I go to data analysis. And let's say I just want to do descriptive statistics first. You don't really have to do that for this, but I always do descriptive statistics. What's my input range? So I click on the data that I'm looking at. I can't make this bigger, sorry.
No problem.
Data is in columns, and there's labels in the front row, so I'm going to do that. I want to output range. I want to put my data on this sheet. I don't want to put it on another sheet. So let me say I click right there. It's going to start putting my data analysis there, and all I want is summary statistics. If this was a statistics class, we'd also do confidence level for the mean, but we're not. And there it goes. It gives me all this stuff. So for payroll and wins, X, boom. I don't need this. I don't need to do it again. Let's say delete. So there's my wins. My average number of payroll, my standard deviation, my standard error. Let's make it all one decimal place. I don't need all those decimal places. Home. Okay. It has standard deviation, sample variance, kurtosis, and you really don't need those, but I'll leave them there just because they're there. And I may make those 3 decimal places. Kurtosis and skewness is it have one tail longer than the other is a skewness, and the kurtosis, I don't even remember. I don't even use it for anything. But then the range. It tells me from the max versus the minimum is 106. There's a range of from the lowest to the highest. It's $165 million in salary. It goes from 43 to 209. In wins, there's a range of 39. It goes from 61 to 100. It gives me the sum of all those variables, which I don't need, and it tells me there's 14 teams. Why do I need that? I don't know. I just always run descriptive statistics. It's not a requirement for this. Well, let's do something else. Let's now use data analysis for regression. So I go to data, I go to data analysis, and now I'm going to go to regression. I say, okay, it opens up another dialog box. What's the Y range? Here's the Ys. I'm trying to predict the number of wins. I'm really interested in that. Where's the X range? I only have one X variable, but if I had more than one X variable, I would highlight several columns. But I only have one. So I go here. Boom. I've got that. The labels are in the first row. I want to output range again. And where's my output range? I'm going to put it right over here next to the descriptive statistics. Do I want residuals? I don't want any of that stuff. I'm not worried about that right now. And I click OK. Now it gives me a lot of stuff. What does it give me? It gives me my R squared of 0.0308. And maybe I'm going to make this, I think I'm going to make these all 3 decimal places. Because I don't need so many decimal places. I'm not flying rocket ships to the moon. And it talks about here, really, I want my significance. I want that probably 3 decimal places. This is an important, what are the important things here? I want to look at my R squared, which is the same as the R squared there, 0.0309. If I made it 1 decimal place more, it would be 09. So that's the same number. Don't worry about adjusted R squared. It only matters if you have multiple X's. And the significance number of 0.058. I want that to be under 5%. It's way over 5%. I would say this would be a statistical test that tells me I am not happy with this model. I'm rejecting the model because of that. The p-value for the payroll is the same as this. If I make that also 3 decimal places, you'll see it's the same number. These two will always be the same number. This does a hypothesis test that says, these are important number 2. These are the coefficients. What does that mean? Well, there's my intercept is 78.391 right there. 0.043 is this number, 0.0436. So those are the multipliers. This would be, if I was to write it that way, this would be my M, the slope, and this would be equal to the B, and they call it intercept, but I would call it y-intercept, okay? So this gives you the same information as that, but this does 2 significant tests on it. It tests the significance of each coefficient to see is it important to the model. If it's above 5%, it's not important. These are 54%. This is not a valid model. And I don't even have to run the other tests because if I take the Yankees out, it gets even worse. I do not have a model here. I would not use this to try to predict anything. So we've just concluded that payroll has no impact. It has a very small impact on the number of wins. It only accounts for 3% of that variation in the numbers of wins. And yet baseball teams will pay money to get the best players.
Yeah, right.
But they put it together and does it really work? Okay. That's a lot of stuff in a few minutes.
I appreciate you taking the time. Thank you.
Well, and let's see, what else we got? Are other people on the call yet? Lots of people are on the call. How much of that did you catch? We can go over it again.
It's fine. I don't want to pull away from a regular meeting.
No, this is the regular thing. I think Jenna had asked for the same thing too.
Okay. I may have to pull out.
That's okay, but you got this, and you got you'll be able to watch the video. You know where it is now. It's in the chat.
I'm not sure. I'll know in 5 minutes whether I have to pull out or not.
Okay.
Because I'm gonna open a window if I'm online teaching. So if the class is coming in, that means I'm teaching at 8. If not, then I'm teaching at 9.
Okay.
My time. Okay.
That's kind of interesting the way they let you know. The class shows up, teach it.
Well, it's.
I'm kidding.
They took the schedule, the regular in-class schedule.
Let's not worry about that. Let's get back to statistics here, or regression analysis. All right, let me show you what I did. What part did you join in on class?
So I'll for about 7 minutes. I saw the tail end of you getting the statistics report out there with the coefficients and all
right, let's start
very
again.
little, I think.
Let's start again. I looked at problem 431. Where's my textbook? Around here somewhere. In my finder? Oh, there it is. It's in the teams thing. I found this problem 431. In 2008, the total payroll for the Yankees, blah, 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 blah. I didn't care about it. I just wanted the data. You can read the blah, blah later. It's problem 431. So I took a picture of that data and put it here. Because it's a picture, I can't do anything with the numbers, right? It's not, the numbers aren't in Excel. So the first thing I did was copy these numbers and put them in here. And when I did that, I made sure that I had all 1 decimal places in this column, no decimal places here. This is payroll, and instead of number of victories, I just called it wins. Now the question I would ask you, and let me get rid of all this stuff because we're going to do it all again. What is my dependent variable? What is my independent variable in this? And if you don't know what that means, say something right now. And don't worry about outing yourself that you didn't watch the video or didn't read the chapter yet. It doesn't matter. This is about learning.
Yeah, I have no
So I may
idea.
get it wrong. Oh,
I'm sorry?
I was going to say I said I may get it wrong. The independent variable would be your payroll here, right? It's fixed, and then your dependent would be, in theory, dependent upon that, right? It wins.
Right. By process of elimination
Yeah.
in this case, right? Okay, yeah, you're exactly right. The independent variable means I can do something about payroll. But what I'm trying to do, and another way of looking at independent and dependent, which one am I trying to predict? Am I trying to use wins to predict payroll, or am I trying to use payroll to predict wins? As a CEO, as the owner of a baseball team, which would you be more interested in?
I don't know if my money is buying a win.
I'd want to find out if I'm investing, if I invest more, will I win more, right? So this is the X variable, which is the independent variable. This is the Y variable. We're trying to see if it's dependent on this. So while I can control this as a team, right? I mean, it's not like the payroll is an independent thing. Oftentimes this ends up being time, like year or month. I can't control what month it is, but I use time to try to predict something like sales. In this case, I'm trying to use payroll to see if I can predict wins. And I'm trying to find a model that tells me Y equals, and this is like 8th grade algebra all over again, mx plus b. And this is called linear regression. The variables here are m and it's b. It's linear in those variables. I'm trying to predict those variables. What's the first thing I do with data like this? I highlight it. I go to insert. I go to recommended charts. I click on scatter diagram. And boom, it gives me this. Very nice. There's the Yankees, which has a payroll of 209 and 89. I don't need to put the names of the teams here unless I want to. I've already got the names of the teams here. I'm interested in having this data in Excel so I could like make graphs like this. Now, I want to fit the best line to this. If I was to just look at it, I think I could fit a line like I eyeball it right through there, right? Would be the best. Half the points above it, half the points are below it. In fact, I was telling Constantine earlier that back in the day before PCs and computers, if I had a small data set like this, I would use good engineering graph paper, actually plot the points, extend the data to the y-axis to predict what B is, which is the y-intercept, and then pick 2 points and show the change in X and show the change in Y to estimate the slope. And we used to do pretty good. with that. I mean, as long as we're not flying rocket ships to the moon, which is my, you hear me say that way too often. If it was something that didn't have to have precision to several decimal places, that was fine. There is a much easier way to do it now. This is called simple. First of all, when I have two variables, I have one X variable and I have one Y variable. That's called simple linear regression, SLR. One X variable, one Y variable. When I have multiple linear regression, I can have many X variables. I never have many Y variables. That becomes really, really a hard problem that just forget about it. We're not even going to go there. We only have one thing we're trying to predict at a time. Y. One Y. In this case, it's wind. And the only variable we're using to try to predict it is payroll. Because most people think if you spend a lot of money, you'll win more. Even though I think we've shown that that's not always the case. You know, the team is made up different than the highest paid players you can get or the most talented player and everything. Will they gel as a team? Okay, I'm not going to get into the philosophy of that at this point. It's not a class in that. So I go here where it says, so I did chart design. That's where I went. I'm in chart design because I clicked on a chart. If I click off the chart, that goes away. But if I click on the chart, it goes to chart design. I go to where it says quick layout. And I have so many different options I can have for this chart. I can make it look like that. And now I can put my, payroll in millions and stuff like that in there if I wanted to. Or I could go there and I could make a chart that looks like this, where it puts all the labels. And there's too many data points. It's more confusing than helpful. The one that I want is the one where it says f of x and it has a line through the data. This is the regression equation. Now I want that numbers, but I want to put it where I can see it, which is up here in this corner. And in fact, I have a little habit. I'll tell you what it is in a second. I get rid of that. I don't need it. I know that there's only two variables. I don't need a legend to tell me what it is. The dotted line is a regression line, and the dots are the raw data. And it's about where I would have eyeballed it, so that's good. The trick I do all the time is I go to the home, I go here and I make it this dark maroon color and I make it bold because this is my regression equation. It says 0.043 times X, which is times the payroll, plus 78.391 or 78.4 will give me my number of wins. Right? That's what it tells me. And it also gives me an R squared number. And R squared is 0.0309. So if I'm just using this simple graphical method of doing it, it gives me my regression equation and it gives me my R squared. What is R squared? It's called the coefficient of determination, which doesn't mean anything to anybody, except maybe the person that first said it. Doesn't mean how determined anything is. I don't even know how they named it that. It's like denominator and numerator. No one would ever name those things today. They would call it top part of fraction, bottom part of fraction. And most people don't say coefficient of determination, they say R squared. R squared represents the percentage of variation in the Y data that is explained by the regression model. Cool. 3.09, 3.1% of the variation in the number of wins is explained by this model. That means payroll is only accounts for 3% in the data that we're looking at. Most people will extrapolate this to all teams in any sport over the history of mankind. No, all we can say is it applies directly to this data, which was the 2008. It looks like it was the American League. Now, I will point out something else to you. So based on this, I would say, I don't think this is a very good model. Plus, one thing that I would notice that you might not notice, this point here, the Yankees, is separate from the cluster of the rest of the data. When I have one point that's farther away from the rest of the data and I'm trying to apply a line, all of these points kind of look like one point. This looks like another point. This helps define where the line is going to go. And the farther out it is, the more it's going to dominate this regression model. If you understand what I'm saying, it will pull the line in wherever to its location, the farther away it is from the rest of the data. Some people might call it an outlier and try to get rid of it. Everybody wants to call something an outlier. I'd be very careful using that terminology. And in fact, I would forbid you as novice regression experts to call anything an outlier. Not that anybody ever listens to such forbidding kinds of statements. Now I highlighted the data without the Yankees. I go insert. I go here. I'm going to do it again. I'm going to do another chart. Does this chart look as compelling as the first one? Does it look more scattered? Is there a pattern in here? I see a pattern here, but I also see data all over the place. This looks pretty scattered. I don't see a general pattern in this data. But what do? I do the same thing. I go to this FX and I move this and I get rid of this thing. And if I want, I can put what? Here I'm going to put payroll in millions. If you turn charts into me, you should label them. So I know that you know what it is. I know what I will probably be able to figure out what it is. Wins. And I use wins instead of victories because it's just shorter. And if the chart title, I might put wins versus victories, wins versus payroll. God, I can't type at all. Good thing I know something about regression. Totally useless here. I could do the same here, but I'm going to highlight this again. What do I usually do? I go home, I make it maroon, I make it bold. If I want, I can even make it bigger. That's the important part of this chart in this week's homework. You can do any simple linear regression, one X variable, one Y variable, doing this. You can. It doesn't take anything to do it. It's relatively simple. I mean, you have to do it a few times to get used to it. Where was that? Where do I click? What do I do? I mean, you can watch this video over and over again. But notice what happened. My R squared went down to 0.0079. It's not even 1% of the wins are explained by this. See how this data point pulled the data further and made the, if I was to make this point, if I was to make the Yankees have 200 wins, it makes the line, see how it made the line go up even further? Let's say I made it, and let's say I made the point of, let's say they paid $300,000, $300 million. How that one point drags the regression line to it because it's so far from the rest of the data. And notice I went up to, now I'm explaining 69% of the variation in the data with this. Because this one point dominates so much. Remember, 2 points to determine a line. If I take this cluster as 1 point, and this is another point, it's going to try to draw the line through it. So the further I draw this out, the higher these numbers go. So you got to be careful if you have one point that's way out there without calling it an outlier. An outlier means it doesn't belong in a data set. Does the Yankees belong in a data set? I don't know. So many people hate them. It probably doesn't. They would think, the rest of the league thinks they shouldn't exist, probably. But that's not the point. Was that clear to everybody?
Yes.
Thank you. I'm waiting for that verbal confirmation. Okay. I want to do a couple other things, and I'll show you this. I'm going to get rid of all this stuff first. Boom. Let's see. Delete. You can watch me do it twice and see if, I mean, because I've explained it once for Constantine, now I explain it again for you guys. Okay, so this is one way of doing it. This is really quick and dirty, fast, easy regression. One variable, simple linear regression, 2 variables. So it's graphical, or the graphical method of doing it. It can't get any easier than this. For the discussion, this is what all you need. You can do whatever you want. I'm telling you, this is what you need. People won't listen to me, but that's okay. All right, now there's another way of doing it. Has everybody loaded up? If you go to your data, have you loaded up data analysis and solver?
I have mine now.
We did Constantine's. To do anything else, you have to use QM, but QM will rely on, I'm not going to use QM. I just like using data analysis for this chapter. You can use QM as well. It does kind of the same thing, but this is cleaner. And then I'm going to show you something else we can do with this data afterwards. All right. Let me go around one person to person. Andrew, do you have data analysis on your Excel?
I am looking for it right now. I have a what if analysis. I don't think that's it though.
No, you don't have data analysis. You have to load it. Do you have a Windows PC or a Mac?
I do. That's Windows.
All right. Everybody that has a Windows PC can watch as Andrew shares his screen with me.
All right.
I'm going to unshare my screen and pull up an Excel file.
Sure.
There we go.
See an Excel file
Look,
here.
you got all kinds of stuff going there. I love this. You probably have too much scatters on one thing, but that's okay.
I may.
Very
Where am I
interesting.
looking?
Okay. Go to File. Go down to where it says Options, very bottom of that first column. And you clicked on that, and now go to Add-ins. Click on that. Now, this is really weird because all you have to do here is hit Go.
I was right on it. So it's
Right at the very bottom. No, don't click on any of that. Doesn't matter. Just go to Go on the very bottom.
Next
thing. Yeah. It's
right
like
here.
an unnecessary thing. It doesn't.
Got it.
Now you have all this stuff. You have some other stuff on there already. Wow, look at you. Click on Analysis Tool Pack. And click on Solver Add-in.
Okay.
And go OK. Now go to your Data tab, and it should show up there. Unless this is a work. Yeah, there it is. You have Data Analysis and Solver. Yep. So if you have a Windows PC, that's how you do it. Let's go back to my screen. And I'm using a Mac right now. So if I go here, I'm not exactly sure how to do this. I forgot all the time. Because once I do it, I don't, there's no need to remember. Page layout, insert, draw, review. It's under data. Oh, analysis tools. I think you click there and it tells you which one you want to do. If I want to browse, no, that won't help me. I think you just click on analysis tools and click the ones you want. Or maybe that's, I don't know. I forgot how to do it. There's a video I put up in like week 2 that tells you how to do that. Or maybe week 1. Formulas. Some look up. Well, let's do it the easy way. Adding solver in Excel on a Mac. Open Excel, go to Tools menu, and select Add-ins. Okay, so it's a Tools menu. Where's Tools? Do we have a Tools menu? Where is the Tools menu? Check Solver Analysis Toolbar, click OK, and then it should be in your Data tab. Do I have a Tools? If we go home, I don't see Tools anywhere. Oh, fun. Oh, it's up here. It's up at the top. It's at the very top. It's at the very top. Sorry. And then you go into Excel add-ins, and these would be unclicked. You click on them. And then you say, OK, and they miraculously show up in your Data tab. Yay. All right. So now I'm going to try to use, the nice thing about data analysis is it's a full statistical package in Excel. Real serious statisticians don't like it. They think it's not accurate. For anything that we're going to do, it's more than accurate enough. If I was like, again, flying rocket ships to Mars, I might not use it and rely on it totally, but for most business applications that I'm thinking of, that's not big data. And what do we mean by big data? Data sets that are so large that if we put it in Excel, it would slow down your computer to a crawl. You can't use Excel to solve it. All right, so the first thing I like to do, you're not required to do this, but since I'm teaching, I'm going to go through this. I go to Descriptive Statistics. I say, OK. And let me get rid of all this, because I've already clicked on things, so it remembers the last thing I did. I go here where it says input range, and I can't make these pop-up windows any bigger, sorry. I click on payroll and wins, and I do the whole shoot match. Copy all the data. And I'm going to tell them my data is in columns. So I have 2 columns, 2 sets of data. And I click on labels in the front row because I did put payroll and wins. Now, usually it wants to put it in a separate worksheet, but I like to put it in the same place. And I'm going to click it right here, this Q, whatever, 3 cell. And I click on summary statistics, which is what I want. If it was a real stat class, a full stat class, I would also click on confidence level for the mean, but we're not covering that, so I'm not going to bother you with it. Then I hit OK. Woo, calculate stuff quickly. I'm going to move these columns, copy, paste over so that they're over what they're supposed to be, and I'm going to get rid of the duplicate labels. And what do I have? I have my mean, I have my standard error, which you don't probably know what it means yet, and so we're going to ignore some of that stuff. I go home, probably make these 1 variable. I'll probably make all this stuff 3 variables. Kurtosis and skewness, you're not going to need. Skewness means if one tail of the distribution is way longer than the other tail. But I've got my mean, I've got my standard deviation, I've got my range. It says the salary has a range from max to min of 165 million, and the number of wins from min to max is 39, and it gives me my minimum number of salary, my minimum number of wins, my maximum of both. It gives me the sum of all the wins. If I was to sum up this column, it says down here it's 1364.8, 1364.8, and there's 14 of them. There's 14 of them, and it gives me the average 97.5. So that's what that does. Why do I do that? The same reason I draw a scatter diagram. I just want to see what I'm dealing with the data. I want to see what it looks like if I can graph it. And I want to see what the descriptive statistics are. But now I want to do something else. I want to go into data analysis again. And I think there's even an analyze data tab here. I don't know what that does. Yeah, I like data analysis. That's what I'm used to. That's what I'm used to teaching. I feel like an old dog. I don't want to learn any new tricks right now. So I'm going to go to data. I'm going to go to data analysis. And now I'm going to go down to where it says regression. That's what we're doing. I say, okay. And it's already got my data highlighted here, but let's pretend it wasn't highlighted because it remembers what I last did. And let's take all this stuff out and put it at the defaults. Okay, there we are. So I start, what's my Y data? Well, I go here where I'm going to put the Y range in, and I just do this. And notice I did the labels again at the top, so I want that. Now, if I was going to do the X data, if I had many X variables, I would highlight all of it, but I only have one, so I'm just going to highlight this one column. Oh, I put it in the Y data, which is it possible to do? Yes, it's very possible to do. If a mistake can be made by a human being, it can be made, and it can be made by me. It can be made by you. So I got that. I don't click anything else here. I click on output range, and where do I want to put it? I do want to put it right there, which is U3. And I don't need any of these residual analysis. It's too short a section on regression to get into any of that stuff. So I click OK, boom. Now it gives me all kinds of stuff. Okay. It gives me an analysis of variance table, what they call that. What do we got here? What are the important numbers? Let me take these down to like 4 decimal places. I think I took it down to 3 last time. I'll take it to 4 this time. There's a reason for I'm taking it to 4. Okay. My R squared is right here. Is it the same as the R squared we got over here? 0.0309. Yes, it is. Yay, good for us. It gives me my analysis of variance table for the whole model. It says basically, if it's a hypothesis test where it says, let's insert text box. I didn't mean to do that. Insert back text box. H0. No regression model. There's the model, we don't have a good regression model. H sub A, we have a good regression model. What this usually means when we have 2 variables, what that means is M, the slope is equal to 0. Good regression model means M is, I don't know, I don't have the not equal sign here, I don't think. So I'll use this. Not equal to 0. And we do this at a significance which is an alpha value, most statisticians call it, of 0.05. This number here, the significance, this is the significance of our model. This is also a test on specifically asking, and it's the same number, mind you, if, and we'll call it p-value, if the slope, this is the slope, the payroll here is equal to m equal to slope, the intercept is equal to b, and I want to put space in there, and I'm going to make the ones I'm highlighting in yellow are the numbers you're going to really pluck off this thing. Well, let's make these, what do we say, 4 decimal places. 0.0436, there's the slope. 783907, 78391. Well, if I round it off to 3, it'll be 1. Okay. Significance also equals a p-value. P-value is a calculated significance, is another way of looking at it. Oh man, I don't mean that. I mean space equals p-value. So I'm not putting a formula in. Oh, I don't mean that either. As 0.54 is way greater than 0.05, we do not have evidence to reject the null hypothesis. So we have to stick with our status quo conclusion that the slope is 0, which means we have no regression model. So I have this, and I have this, which also says it's bad. And I have 3 confirmations. I can look at this visual data. It's not impressive to me. I have the R squared, which we interpret as saying we're only explaining with this model 3% of the variation in the Y data. So the payroll only contributes 3% to the salary. And then I have a hypothesis test that tells me my slope is 0, which means that basically this scatter diagram is a pure scatter and not, I can conclude it's a pure scatter. So all of a sudden I would conclude that I cannot use payroll to predict the number of wins. Okay, I've got all that. And if that's not enough, and maybe it's not enough for you guys, let's do some other stuff. Let me move this over. I might make this smaller. And I might make this smaller. You can always make them bigger again. Why am I making it smaller? I want to do some stuff over here. I have, let's look at, let's make these smaller too. And what do I want to do? I want to have, in fact, I'm going to put these underneath. Get them out of the way. We're done with that part right now. So let's go back up here. Payroll and wins. Now I don't have to worry about making them small. Make them the same size. Okay. Predicted wins. Okay. What are my predicted wins? I have an equation. 0.0436 times the payroll. 0.0436 times the payroll plus the intercept, which was what? 78.391. 78.391. That was what they predicted the Yankees would win with this model. And if I go down all the way, drag this all the way down, it gives me how much everybody should win. And let's take it down to 1 decimal place, right? You can't, well, just take it down to 1 decimal place. Okay. Predicted wins. Let's make it bold. Let's make it right justified. Now I have absolute error. I have error squared. And I have percent error. Absolute percent error. So now I'm putting some metrics on these things, right? What's my absolute error? Well, it equals ABS for absolute value. Well, first of all, let's try it without the absolute. Let's just say it equals predicted minus actual. Right? And let's say I sum all those up, equals sum of all this stuff. The sum comes out to 0. Listen, the regression line is designed to have half the points above the line, half the points below the line, trying to fit the best line in between this data. If I take just the error by itself and take the average, it's going to come out 0 because half the points are above, half the points are below. I can't do it that way. I want to look at the absolute value of that. And you have to excuse me, whatever cold I had last week is now threatening to turn into laryngitis as it's draining. I'll put a cough drop in my mouth. See if that helps. All right, I want to put ABS, absolute value, and put parentheses around what I'm trying to do. It's going to give me the same numbers, except it's just going to tell me the difference, the positive difference between it. Instead of now it adds up to 121. But I don't really care about the sum. What do I care about? I want the average. I want to find out what my average number of deviation and wins are using this method. Now I don't care if it's plus or minus deviation. Mean, absolute deviation. That's what it stands for, MAD. Mean, which means average, absolute deviation. And that's what we have. Absolute error, absolute deviation is the same thing. Okay. So let's make this. Am I okay with plus or minus 9 wins if I'm going to use payroll to predict the number of wins? I don't know. Plus or minus 9 wins is how many places out of first place? I don't know. Well, let's look at my error. If I square the error, I also get rid of the negatives. So there's I'm going to take the error here and basically square it. Do I need all those decimal places? Absolutely not. I'm going to take it down to maybe 2 decimal places there. And I'm going to copy this all the way down. And then I'm going to copy the average over. So this is my mean squared error, my average error of the squares. This used to be the only measure people ever used of forecast accuracy. And it's because that means something to statisticians. Statisticians square everything to get rid of negative signs. Why do they do that? Because they think the world they think about the world in terms of standard deviation. The one that's most popular now in business is absolute percent error. You tell me if I'm wrong, Colby. Which says, what's my error? There's my error. I'm going to divide it by what? Actual or predicted? I want to find out how far off I'm off from the actual, don't I? So it says I have let's make it a percentage to 1 decimal place. I'm off by 1.7. And if I take the average of those, I get 11%. And we'll call that MAPE, mean absolute percent error. In fact, you hear people talking about MAPE all the time. So what do I want to do now? I want to make it pretty because I might want to show this to the boss. There we go. What color do I want to put in? I want to put in a little blue tint. And I usually make these different colors. I don't know why. This is going to be helpful for your next week in the homework, by the way. I don't want blue. I want green. Yellow. And orange. All right. Am I okay with 11% error using this model? Well, I guess I'm this team. They spent about half of what the Yankees spent, a little bit more than half of what the Yankees spent, but they did horrible. Here they spent half of what the Yankees spent, but did better than the Yankees. So remember, this is on the average. Am I okay with it? Can I use this model to predict? I don't know. Am I okay with 11% error in the number of wins? That could be plus or minus. I would say taking these out of the picture, the R squared and this value, these significance values, which happen to be the same in these models, make it not a fun model. I would not use this. I would not use this model to try to predict. Based on this only, I would conclude payroll is not a good predictor of number of wins. Any questions? I covered a lot of stuff there. Whose brains are full?
Good rundown.
All right, let's do something else. Then we'll get to the discussion. I really want to get to the discussion. If we go to the textbook again, let me share my screen. Should we stick with baseball?
Sure.
Why not?
That time of year.
It doesn't matter. It's just data. I don't even care what the data is. So we look at 32. The 2009 New York Yankees won 103 baseball games during the regular season. The table next to on the next page lists the number of victories, wins, the earned run average, and the batting average of the team. Not a bad thing. what we're going to try to do is see what would we try to predict again? What are we interested in predicting? Let me copy this data set. And I'll put it in Excel and make it look bigger. This is 4-32. What do we want to predict? I'm a baseball team. What do I make money off of?
Winning.
Wins.
Win. I want to predict wins again. But now I have two. And you know, baseball is as good as your pitching and your hitting, right? Basically. What else might I include in here if I was interested?
Runs scored.
It could be runs scored. It could be, I mean, we could get into the whole Moneyball thing, right?
Right.
It could be errors. It could be all kinds of stuff. But all I have here is ERA, which is a measure of the effectiveness. Let's turn it this way. The effectiveness of the pitching. The lower it is, the better.
Sure.
And the batting average of the team, which the higher it is, the better.
Yeah.
So I have two X variables to try to predict a Y variable.
Right.
Now, if you knew nothing about baseball, and I imagine some people on the call know nothing about baseball, it doesn't matter. It's just data to me.
Okay.
But it's always good to have one person called a subject matter expert. What is this ERA? You need someone to tell you what it is. What is this average? Average what? Average height, average weight, average IQ, right. Average, what are we talking about here? But it's batting average. The number of times a person comes to the plate and gets a hit. So I always, having a mathematics background, I'm going to call it batting average to make it clear what it is. And this is ERA. I know what that is. It's earned run average. And then I have wins. This is my Y variable. These two are my X variables. I have two X variables this time. So now instead of, I'm not looking for a model that says Y equals MX plus B. I'm looking for a model now that says Y equals, I don't know, what do we call it? You could call it anything, but let's call it M1 times batting average. Let's call it BA for batting average, plus M2, a slope-ish, a coefficient that I multiply times ERA, plus some sort of constant in intercept. Usually, the way people would label this is they would use B's for everything. They would use B2, B1, and they usually call the constant with no variable around it B0. Well, it's called B, we're using numbers, which is B0. We think when we use it to predict, this and this are the variables that would go into the calculation. But when we're doing regression, the variables that we're trying to find are the coefficients. And we're using this real data to find it. Now here's the tough part. I have to put all my numbers in here now, because it's useless. 103, 97. You tell me if I do something wrong. I have 5 proofreaders, which is I never have. 87, 87, 86. 85, 84, 79, 85, 70. What do I try to do? 3. I should only do 2. 84, 79, 75, 79, 75, 75, 65, 75, 65, 65, 64. Did I do them right? Okay, now put the earn run averages in. 4.26, 4.45, 4.35, 4.5, 4.38, 4.29, 3.87, 4.33, 4.14, 4.47, 26, 5.06, 4.83, 5.15. All right. Batting average, 0.283. I could just make it, I don't have to even, if I didn't want to use the decimal place for all of my, didn't have to, right? I could just write 283, 285. But I'll keep them accurate. I just have to know how I write them. 270, 274, 26, 26, 258, 8.263, 0.258, 0.266, 0.262, 0.264, 0.259, 0.268. All right, there we go. Look at us. We got some stuff going here. Put things around that. I'll make these so predictable. I can put it in the PowerPoint easily. Okay, let's just look at this. The easiest thing to do here, insert, recommend a chart. Let's look at a scatter diagram. Very different scatter diagram here, right? I see a downward slope here, and maybe it's going to have a good fit. I don't know. I can't predict this. There's a lot of cluster in here. There's a lot of noise, right? It's going to be hard. I'm not going to get a high R squared probably because there's a lot of vertical variation on the same X values. So same ERA could give me different number of wins. But how do I do it? I go to quick layouts. I do this. And I get what? An R squared of 41%. I'm explaining 41% of the variation in the number of wins by batting average, aren't I? Or ERA, I'm sorry, by pitching. ERA, wins. Good for me. I like this. Wins versus ERA. Want to do the same thing for batting average? Okay, I forget. Oh. I'm doing batting average, so I've highlighted those two columns. Insert. recommended chart. Very different scatter diagram here too, but this has this looks more like a pattern than the salary, doesn't it? What do? I go to the same place. Boom. Look at me doing analysis here so fast. I'm explaining 34% of the wins with batting average. What is this? Batting average. And this is what? Versus batting average. Okay. I'm doing pretty good. I like this model. I could almost like either one of these two, right? 34% is pretty good. 41%. Maybe if I use them both together, I'd get 71%. Maybe. That's what we want to do next. So far, I'm like, I could use either one of these models. I think kind of more than I would use payroll. All right, so how do I do this? I'm not going to go through descriptive statistics again. It'd take a waste of time at this point. Oh, the one thing that's not a waste of time, same number of variable. I want to have the same number of decimal places here. Why? I don't know. This is what I do. It's what you should do. This looks cleaner, looks better. Okay. I'm going to go to data analysis though. Now I can't draw 3 axes, can I? It's hard to make a graph. That's why I made each individual one. But now I want to do a multiple linear regression. I go data. I go data analysis. There's regression. And notice it still has my data from last time again. So be careful, zero that out. And my y-axis, my y data is the number of wins. But now my x changes. Instead of just highlighting one column, I'm going to highlight both columns. It'll figure it out. Labels in the front row. Where's my output? U. We don't need U3 because that's too far away. We don't have the descriptive statistics, so let's use Q3. And I don't need anything else here, so just say OK. Ooh, look at my R squared. It jumped up to, and I'm going to use adjusted R squared too. On multiple regression, you probably should use adjusted R squared. Trust me. R squared or adjusted R squared. I don't know if they're close, use either, but adjusted R squared is supposed to be the better number. And let's make that what? Home, insert, make it yellow. That's an important number. Here's my coefficients. If I want to do predictions, I do minus 24 times the ERA, minus 24.7 times the ERA, plus 907 times the batting average, because the batting average, remember, was a percentage. Minus 49 for the intercept if I want to predict the number of wins. Now, look at this. My significance and my p-values. I don't ever worry about the intercept, but look how low these numbers are, below 0.05. I could use a significance of 0.01, and both of these are important. I could use a significant, this is, if I make it a number, it has 5 decimal places of zeros. So this is really a compelling model to me. I'm dancing in the street. I'm explaining 84. If I did 34 and 41, that's only 75%. Put them together, it makes 84. This is a model for me. I would use this model like crazy. I have really strong significance levels. The lower these are, the better. And they're essentially to 3 decimal places, 0 in every case. So to me, I've got this is a winner. And you see the synergy of applying to. Now, if I have several variables here, let's say I could do something else. Let's try something. You want to do something really crazy? Copy. And let's paste it down here. And I'm going to move my win column over. Over to here. And I'm going to add two more variables. I'm going to use batting average squared. And I'm going to use batting average times ERA. Why am I using it? I mean, there's no baseball value to using it. I'm using it to show you an example of what we could do. I'm making it a polynomial, basically, right? I'm adding a squared term. I'm multiplying two x variables together. So how do I square this? I say this is equal to that squared. And let me take that down to 3 decimal places. And let me do the same thing for here. I'm going to make this equal to that times this. And don't do it willy-nilly. You should have some reason that you're thinking about doing it, right? Don't do it because, well, professor just randomly squared a variable and random. Oh, I don't mean to do that. I mean to do this. Okay, let's leave it like that. All right. So now I have 5x variables. You say, so really my model looks like something like this. The model I'm looking for is going to say, let's center and merge these, and it's going to say wins equals B5 times batting average plus B4 times ERA plus B3. Okay, I just meant to make that. Okay, this is B4. 3, 2 times BA squared plus B1 times BA times ERA plus then a constant plus B sub 0. That's the model we're trying to predict now. That's really horrible. If you wrote it as an equation, it would probably look better. Let's put a box around it. Okay, so now what do I want to do? I want to do the same thing. I'm not going to draw any graphs here. I could graph each one of these with wins and just see what it looks like if there's anything there. But that's not what I'm trying to do here. I'm trying to show you how to do with many variables and then how you make some decisions when you do that. So I put data analysis, regression, and it's going to say, okay. And I really want to go back down here. It's going to ask me where my Y data is. Hopefully it will stay there, but I want to do this. There's my Y data. My X data, I'm just going to leave it there and go back and forth all the time. I want to take all 4 of those columns. Labels are still there. My output range, I want to put where? My output range, I want to put right there. And I say, okay. Did it change my R-square very much? I can already tell those two variables aren't going to count to anything. If I go here and I look at my p-values, all of a sudden it changed them. None of them are significant. The variables I added didn't do anything. I mean, I already did it with this. Look how significant these p-values were here. And what do I get here? Nothing is significant. Even though it still comes out, the model itself is significant, but not as much as it was before. I would say these two variables that we tried are meaningless. I'm surprised that the p-values on these changed too. That shouldn't have. It really shouldn't have, but it did. Let's go back over here, and what do I want to do? Home. And I'm going to make those orange. And I said I added those, and I don't think they added any value. I'm going to get rid of them. So usually what you want to do is you look at this column and eliminate any variable that's start eliminating, like if it's this case, I would start eliminating the highest one and run it again and see what happens. So you're going to end up running it multiple times and then take the next highest one out and you're going to get this. Oftentimes it comes out where some of them are below 5% and some of them are above that. You get the ones that are higher probability ones out and leave the ones that are already below 5%. This is the first time in a long time I've seen it where this would say none of these variables are significant, but they truly are. We know that these two are already. And we know it says the whole model is okay. I could use this model if I want. It's still giving me an adjusted R squared of 79 versus an adjusted R squared of 81. But this is the model I would stick with. I like this model. I would use it. I think it's predictive to a certain degree. Now, if I wanted to, I could do the same thing I did here. I could add 3 more columns and I could do the 4 more columns and do the predicted wins, absolute error, percent error, absolute percent error, and calculate these measures as well. I would imagine they'd be, if I liked what I've seen already, I'd probably like those. I'll leave that for you if you want to do. What time is it? Ooh, we've gone for an hour and 47 minutes. Was this of value? All right.
Yes.
It is helpful.
Very
All right.
helpful.
I will post the file. And you get the video, but I still want to go through the discussion. So have you posted, any people posted stuff in the discussion?
I think there's
not.
one.
Just one. Who was that one? Let's see who that, or does anybody want to share anything with me? I don't know. Let's go and see what we got there. And I can take attendance too. Firefox. Courses, break course, good for me. I'm sorry about the snafu with the due dates. Week 3 was this is the due date for the homework. Usually whatever's up here. So it was the 10th, but somehow I wrote that it was due on the 17th. So if you didn't do it, I gave it to the 17th. These are due on the 17th. This is the 24th. The discussions are due on the 24th. Textbooks due on the 24th. That's good. This is May 1. Discussion May 1. Textbook problems May 1. This is 2 through 8. And everything's due on the 8th. So I think we're good. That was just, I don't know what I was on. Some sort of hallucinogen, no doubt. So let's look at the service call case discussion. Matthew. Is it okay if we share yours as I'm actually sharing it?
think there's some changes I need to make after watching the presentation tonight.
That's okay. Let's see, based on the data and regression analysis, Q is not a good predictor for STRS calls. Okay. We'll look at the problem in a minute. And how do we do this? Or here, by doing this, you use STR and S calls to predict Q, I believe. You should be using the quantity sold, because I can't control the quantity sold. But if I'm trying to see, if I'm trying to staff my call center, right?
Yeah.
I probably want to use Q to predict my calls.
Okay.
So this is, you're not the first one to ever make this kind of error, but I like what you did here. I mean, he gave it a good shot. Now you use S calls to predict Q in this case. And it's not a good model. The significance is bad, but you're explaining 3% of the variation. Now, if I reverse that, now it's not Q equals M S calls plus B. If I reversed it and made it S calls equals M times Q plus B, the R squared would be the same. It doesn't matter which way I do the regression equation. If I have two variables, it's just based on the two variables. The R squared tends to be the same. But again, it's not compelling. Anybody else want to share any of their efforts? Come on, really?
I have work to do.
Good first effort. Based on my comments, give it another try in class, I should probably put. Another try. Okay, we'll post that reply. And if we look at the actual problem, there's a lot of blah blah in these story problems, right? These case studies. Here's the case. So read the whole thing. This is a guy, Sam. The number of service calls we get in any week or month jumps around so much, it's no wonder that sometimes we seem to be overstaffed, while at other times we're completely swamped. Blah, blah, blah. Customers would like to file formal written trouble requests. Basically, do they email or do they call? Do they email or do they call? He's worried about the calls because they can handle the emails. The same people that are doing the calls can handle the emails in between.
What's that? Nah, it's like this stick. I said no. How this stick getting my stick? Come on. Stick, my guy, I said I'm done. You think I want to play with my nature? Nope. Wow. This is my last class. Hold on, wait, look. Yes. I'm good.
All right, you gotta mute yourself if you're not talking, if I'm talking. So I don't get to hear the other stuff there. And if we're gonna hear the other stuff, it has to be loud enough where we can actually enjoy the conversation. So we can really eavesdrop. Okay. Month. I could use month to predict things, right? I mean, next week, all we're going to talk about is trying to predict sales. And all you have is your previous months to try to predict the future months. We have the quantity sold. We know this. We could use this to try to predict S calls. But really, it ends up being using this to try to predict this, S calls, and you can do it all graphically. You can do it this way if you so choose. But I'm telling you right now, this is all you need. It's a simple linear regression problem. We're using Q. And if you're trying to try using month to predict it too, you could try that. But we're using Q to predict S-calls. Okay? So give it a shot. I think I provided an Excel file. I mean, this is nice of me. You don't have to actually enter the data. I think I provided this. Yeah, so you have the data in here. You don't have to enter the data. I would use this trick where this is try number 1. And if you want, just copy the data over to each time you try it. And then do what you're going to do. Use the columns you're going to use, the columns you're not going to use, whatever you want to do with it, play with it, and then do something. Then make some comment whether it's good. Then, try number 2. And sometimes when you do a try, you might want to put a text box to say what it is you're trying to do, so I don't have to figure it out. So give it a shot. This is your job. I'm empowering you to help. I made you consultants to this fellow Sam. See if you can figure out a way to, can we help him predict how to staff his call center any better? And we've seen here 2 examples. Here's one where, gee whiz, it doesn't look like payroll really helps to predict the number of wins. It doesn't look compelling on the shape of the graph, the R squared, or the regression analysis of variance. But yet, when we used either ERA or batting average, by themselves they were good. When we put them together, it was really compelling. When we tried to use the square and that, it wasn't. So there's some madness to the method, right? It's not just, you don't just try stuff. You try stuff because you think it might be predictive. Would I consider adding payroll to this mix? It would be interesting to see if pitching payroll impacted ERA or non-pitching payroll contributed to, had a relationship to batting average. There's a curiosity there in my mind, but that's it. All right. Should we keep going? Or is your mind full?
I wouldn't complain about being able to work on the regression problem and getting my post up.
You want to do what?
I said I wouldn't complain about taking some time to work on the regression problem and getting my post up this evening. But if others want to continue, I'm good with that.
Yeah, go with it. I like what you had showed earlier. I saw some interest. You were trying all kinds of interesting things based on what we talked. Maybe you want to try them a little bit. Hey, let's look at this first, and let's look at that, and let's see what we got. I saw some stuff that looked of interest to me. Any other questions?
No.
All right, I'm going to stop the recording, and then it will post in the chat. I don't know why it doesn't post in the in our Teams.